Hello everyone. In this presentation we are going to see about the discrete Fourier transform, and I am Manimegle L, Assistant Professor ECE, R.M.K College of Engineering and Technology. So the contents of this presentation include discrete Fourier transform and the properties of discrete Fourier transform and the various computation methods of discrete Fourier transform and the applications of discrete Fourier transform. So in order to understand the DFT better, we have to know what is DTFT, that is discrete time Fourier transform. So discrete time Fourier transform is nothing but the representation of the non-periodic discrete time signals as a function of the frequency omega. So here x of e per j omega is equal to summation n extending from minus infinite to plus infinite x of n into e power minus j omega n, and its inverse Fourier transform is x of n is equal to 1 by 2 pi integral over 2 pi x of e power j omega into e power j omega n into d omega. So here the DTFT is continuous in nature. The discrete Fourier transform is the frequency sampled version of the DTFT. So, DFT is a discrete time signal obtained by sampling the DTFT signal at n uniform frequency intervals. The samples of the DTFT are represented as a function of the integer k. Hence, DFT is a sequence consisting of n complex numbers represented by the x of k. So the DFT pair is given by x of k and x of n. So x of k is the DFT of the given discrete time signal x of n, which is equal to summation n extending from 0 to n minus 1 x of n into e power minus j 2 pi into kn over n, where k ranging from 0 to n minus 1. And similarly, the inverse equation, also known as the synthesis equation, which is x of n, is the inverse discrete Fourier transform of x of k, that is equal to 1 by n summation over k is equal to 0 to n minus 1 x of k into e power plus j 2 pi kn over n for n ranging from 0 to n minus 1. So the equation x of k and x of n is called as DFT pair, and the x of k equation is called as analysis equation, and the x of n equation is called as synthesis equation. So the properties of DFT. We have different properties. The first property is linearity. So the linearity property states that the linear weighted combination of two or more signals is equal to similar linear weighted combination of DFT of the individual signals. So the weights are A and B. So A into x1 of n plus B into x2 of n is equivalent to A into x1 of k plus B into x2 of k, where this x1 of k and x2 of k are the frequency domain signal, and x1 of n and x2 of n being the time domain signals. And the time shifting property is the next property. So whenever the time signal is shifted by m units, the equivalent frequency domain signal is multiplied with the value of e power minus j 2 pi k m into x of k, where x of k is the DFT of this x of n. And the next property is frequency shifting or modulation property. So if the frequency domain signal is shifted by k0 units, the equivalent time domain signal is given by the multiplicand of e power minus j 2 pi k0 into n over n for x of n. And the time reversal property. So in time domain, x of minus n, which is the time domain reversed signal, is equivalent to x of minus k, that is frequency domain reversed signal. And the conjugation property is the next one. So x complex conjugate of n is equivalent to x complex conjugate of minus k in frequency domain. And the time convolution property. So the performance of convolution in time domain is equivalent to the multiplication of two signals in frequency domain. And the next property is frequency convolution. The product of two signals in time domain is equivalent to the convolution of two signals in frequency domain. And last, the Parseval's relation. So here E of x is equal to summation n extending from 0 to n minus 1 modulus of x of n the whole squared, and in frequency domain Ex is equal to 1 by n summation over k is equal to 0 to n minus 1 modulus of x of k the whole squared. And next, the computation of DFT. We can compute discrete Fourier transform with basically two different methods. One is the direct or formula method, that is using the analysis equation, and the other method is FFT, that is fast Fourier transform. This fast Fourier transform is an algorithm adopted for finding DFT in a faster method. So that is categorized into two types, which is DIT, that is decimation in time algorithm, and decimation in frequency algorithm. In this presentation, we are going to deal only with the direct or formula method of conversion of a time signal into frequency domain signal x of k. So here comes the first question. Determine the DFT of the given x of n is equal to 1, 1. So the question clearly states that we have to find the DFT of the given time domain signal x of n is equal to 1, 1. We are going to use the DFT formula to find the x of k. So we are writing the DFT equation. So x of k is equal to DFT of x of n, that is equal to summation extending from n is equal to 0 to n minus 1 x of n into e power minus j 2 pi into kn over n for k ranging from 0 to n minus 1. Here the number of sequence of x of n is 2. So given n is equal to 2. So substituting for the capital N, so x of k is equal to summation extending from n is equal to 0 to n minus 1, which is 2 minus 1. So that becomes 1 into x of n into e power minus j 2 pi into kn by 2 for k ranging from 0 to n minus 1. So 0 to n minus 1 in the sense substitute for 2 for the capital N. So 2 minus 1 becomes 1. So k is equal to 0 and 1. So x of k can be simplified and written as x of k is equal to summation over n is equal to 0 to 1 x of n into e power minus j pi into k into n, where this 2 and this 2 gets cancelled. So we get the simplified expression for k ranging from 0 and 1. So we are going to find x of k for the two values of 0 and 1. First we have to find x of 0 for k is equal to 0. So k is equal to 0 means x of 0. So x of 0 is equal to summation extending from n is equal to 0 to 1 x of n into e power minus j pi into, for k we can directly substitute 0. So 0 into n, and this e power term multiplied with 0 becomes e power 0. So simplifying that expression, we are writing it as summation n extending from 0 to 1 x of n into e power 0. So the value of e power 0 is equal to 1. So substitute in this simplified expression, we will be getting only summation extending from n is equal to 0 to 1 into x of n. On expanding this summation, we will be getting x of 0 plus x of 1. So x of 0 plus x of 1, the value of x of 0 is 1 and x of 1 is also 1 from the given question. So 1 plus 1 we get x of 0 to be 2. So the x of 0 value is 2. And then for k is equal to 1 we can find x of 1. So x of 1 is equal to summation extending from n is equal to 0 to 1 x of n into e power minus j pi into k value is 1. So substituting for that into n, and you can simplify this and you can write the equation which is equal to summation extending from n is equal to 0 to 1 x of n into e power minus j pi into n. So now we can expand this summation. So we'll be getting x of 0 into e power minus j pi into 0 plus x of 1 into e power minus j pi into 1. So this e power minus j pi into 0, the first term becomes e power 0. So x of 0 into e power 0, and in here we can get as x of 1 into e power j pi, that is minus j pi. So x of 0 the value is 1 we know, and e power 0 the value is 1. So 1 into 1, and plus this x of 1 value is 1, and e power minus j pi can be written as cos pi minus j sin pi, and we can replace the value for cos pi and minus j sin pi. So cos pi value is minus 1 and sin j pi value is 0. So that is written in the next step. So this 1 into 1 becomes 1 plus, so 1 into cos pi, which is 1 into minus 1, sin pi is 0, so minus 0. So upon simplifying this, we'll be getting 1 plus 1 into minus 1, so which is 1 minus 1. So 1 minus 1, the value becomes 0. So that our x of 1 is equal to 0. So the total d of t of the given x of n is x of k, which is given by x of k is equal to 2, 0, which is x of 0, x of 1. So this is the method of using formula to determine the given x of n. And the next question is, calculate the 4-point DFT of the sequence x of n is equal to 1, 0, 0, 1. Plot its magnitude and phase response. So here we are going to find the x of k for the given x of n, which is nothing but the 4-point DFT, and also we have to determine the magnitude and phase response for the x of k. So we are adopting the formula method here. So we are writing the formula, the DFT equation x of k is equal to summation extending from n is equal to 0 to n minus 1 x of n into e power minus j 2 pi into kn over n for k ranging from 0 to n minus 1. So in here we have 4 elements in x of n, so that our n is equal to 4. So x of k is equal to summation extending from n is equal to 0 to n minus 1. So this capital N could be replaced with this 4. So 4 minus 1 becomes 3 into x of n into e power minus j 2 pi into kn by the capital N, which is nothing but 4. So we can write, and k is equal to 0 to n minus 1. So substitute for n minus 1. So 4 minus 1 will be getting 3. So k takes the value of 0, 1, 2 and 3. In here we can simplify this expression. This 2 and 4 you can cancel, so that you write the equation as x of k is equal to summation n extending from 0 to 3 x of n into e power minus j pi into k into n over 2 for k is equal to 0 to 3. So first we have to find the 4 values of x of k, which is k is equal to 0 and k is equal to 1, k is equal to 2 and k is equal to 3. So when k becomes 0, x of 0 can be found. So x of 0 is equal to summation extending from n is equal to 0 to 3 x of n into e power minus j pi into, for k you can substitute 0, so 0 into n by 2. So here this e power j term is multiplied with 0, so that e power minus j term becomes e power 0. So summation n is equal to 0 to 3 x of n into e power 0. So e power 0 value is 1. So you can replace with x of 1 into 1, and you can expand this summation also. So that we'll be getting x of 0 plus x of 1 plus x of 2 plus x of 3. We know that x of 0 is equal to 1 and x of 1 is equal to 0 and x of 2 is equal to 0 and x of 3 is 1. Upon summing these terms, you will be getting x of 0 as 2. So the next value is k is equal to 1. For k is equal to 1, we can find x of 1. So x of 1 is equal to summation extending from n is equal to 0 to 3 x of n into e power minus j pi into, for k you can substitute 1 into n by 2. You can simplify this expression, so that you will be getting summation n extends from 0 to 3 x of n into e power minus j pi n by 2. And you can expand this summation, so that you will be getting x of 0 into e power minus j into pi into 0 by 2, so it's e power 0, plus for n is equal to 1 x of 1 into e power minus j into 1 into pi by 2, and x of 2 into e power minus j pi into 2 by 2. You can cancel 2 and 2, so that you will be getting e power minus j pi. For 3, it is x of 3 into e power minus j pi into 3 by 2, so that you will be getting e power minus j 3 pi by 2. So substitute the value for x of 0 to x of 3. So my x of 0 value is 1 and e power 0 value is 1 and x of 1 value is 0. So if x of 1 value becomes 0, multiplied with e power any term will become 0. So I am replacing it as totally 0. And x of 2 value is also 0. So 0 into e power minus j pi will become 0. Plus my x of 3 value is 1. So I am replacing with 1. This e power minus j 3 pi by 2 can be written as cos 3 pi by 2 minus j sin 3 pi by 2. So now you have to find the value for cos 3 pi by 2 and sin 3 pi by 2. So cos 3 pi by 2 the value is 0 and sin 3 pi by 2 the value is minus 1. So upon simplifying this expression, it becomes 1 into 1, it is 1, plus this 1 into cos 3 pi by 2 is 0, minus j sin 3 pi by 2 the value is minus 1. So you will be getting 1 plus 1 into this plus this minus j and minus 1 becomes plus 1j. So 1 into 1j. So this totally becomes j. So we can write this as 1 plus j. So my x of 1 the value is 1 plus j. And for k is equal to 2, we can find x of 2. So x of 2 is equal to summation extending from n is equal to 0 to 3 x of n into e power minus j pi into 2 into n by 2. Here we have replaced k using 2. So this 2 and 2 we can cancel and simplify the expression as summation extending from n is equal to 0 to 3 x of n into e power minus j n into pi. So now expand this summation, so that we will be getting x of 0 into e power 0 plus x of 1 into e power minus j into 1 pi, that is pi, plus x of 2 into e power minus j into 2 into pi. So this becomes e power minus j 2 pi, plus x of 3 into e power minus j into 3 into pi. So we'll be getting e power minus j 3 pi. Replacing the values of x of 0, x of 1, x of 2 and x of 3. So x of 0 is 1. So 1 into e power 0 is 1. So 1 into 1. And in here x of 1 the value is 0. So 0 multiplied with e power minus j pi also becomes 0. So totally it is replaced with 0. And x of 2 is 0. The similar logic is applied here. So 0 plus x of 3, the value is 1, into e power minus j 3 pi can be written as cos 3 pi minus j sin 3 pi. So cos 3 pi value is minus 1 and sin 3 pi the value is 0. Upon simplifying this expression, we'll be getting this 1 into 1 becomes 1 plus 1 into minus 1. So 1 into minus 1 will be getting minus 1. So 1 minus 1, 0. The net value is 0. So our x of 2 becomes 0. So we have only one value to be found, that is x of 3 for k is equal to 3. So here k is equal to 3 and x of 3. X of 3 is equal to summation n extending from 0 to 3 x of n into e power minus j pi into n into 3 by 2. For k, we have simply replaced with the value 3. So simplified expression for this is summation n extending from 0 to 3 x of n into e power minus j 3 pi into n by 2. Expand this summation. So it becomes x of 0 into e power 0 plus x of 1 into e power minus j 3 into pi into 1 by 2, which is e power minus j 3 pi by 2, and x of 2 into e power minus j 3 into pi into 2 by 2, so that it becomes e power minus j 6 pi by 2, and you can further simplify this as e power minus j 3 pi plus x of 3 into e power minus j 3 into pi into 3 by 2. So 3 into 3 it becomes 9. So 9 pi by 2. And we can replace the value for x of 0, x of 1, x of 2 and x of 3. So here x of 0 is 1 and x of 1 is 0, x of 2 is 0 and x of 3 is 1. So 1 into 1 for this first term, x of 0 into e power 0 plus x of 1 is 0. So 0 into e power minus j 3 pi by 2 will obviously become 0. So simply replaced with 0. And here x of 2 term is also 0. 0 into e power minus j 6 pi by 2 will also become 0. So that 0 is written here. Plus this x of 3, the value is 1. So 1 into this e power minus j 9 pi by 2 can be written as cos 9 pi by 2 minus j sin 9 pi by 2. The value of cos 9 pi by 2 is 0 and sin 9 pi by 2 is 1. So simply replacing the cos and sin values. So here this 1 into 1 will be getting 1 plus this term 1 into this cos 9 pi by 2 0 minus j into 1. So 1 into minus 1j. So I will be getting totally minus j. So this 1 minus j. So the value is 1 minus j. So x of 3 can be written as 1 minus j. So the value of x of k is 2, 1 plus j, 0, 1 minus j. So these are the 4 elements of the DFT. So now the question is we have to give the magnitude response and phase response. So this x of k consists of both magnitude, that is modulus of x of k, and angle of x of k, which is nothing but the phase response. The magnitude plot. So absolute value of x of k for any complex number, the magnitude value is determined by root of a square plus b square, where a is the real part of the complex number and b is the imaginary part. So here the first element is 2. So we can find it as root of 2 square plus 0 squared. Second element is 1 plus j. So we can write it as root of 1 square plus 1 squared. And the third element is 0. It is root of 0 square plus 0. And the fourth element is 1 minus j, that could be written as root of 1 squared plus minus 1 the whole squared. Upon simplifying these all values, we can find the modulus of x of k as 2, root 2, 0, root 2. So now with these values of modulus of x of k, we can plot the magnitude plot. So checking the values of k in the x-axis and the modulus of x of k in the y-axis, we can plot. So the value of k is ranging from 0 to n minus 1, that is 0 to 3, and modulus of x of k, the maximum value we can find is 2. So divide the scale as such for the y-axis and x-axis respectively. So for k is equal to 0, the value is 2, so plotted here, and for k is equal to 1, the value is root 2, and for k is equal to 2, it is 0, and for k is equal to 3, it is again root 2. So this gives the magnitude response or magnitude plot of the x of k. And then phase plot, angle of x of k. The angle of any complex number is found using the formula tan inverse of b by a, where b is the imaginary part of the complex number and a is the real part. So tan inverse of 0 by 2. So the first element is 2. So imaginary portion is 0. So that we are writing it as tan inverse of 0 by 2. And second element is 1 plus j. So that becomes tan inverse of 1 by 1. And the third element is 0. That becomes tan inverse of 0 by 0. And the fourth element is 1 minus j. So that it becomes tan inverse of minus 1 by 1. So totally the angle of x of k, after finding all the values, it is 0, pi by 4, 0, minus pi by 4. For this calculation, we have to keep the calculator in radian mode and get the tan inverse values. So a graph is plotted for k versus the angle of x of k. So k takes the values from 0 to n minus 1. So 0 to n minus 1 is 3 because our n is equal to 4 here. So k takes the values of 0, 1, 2 and 3. And this angle of x of k takes the values of 0, pi by 4 and pi by 2 along the positive axis, and 0, minus pi by 4 and minus pi by 2 along the negative axis. So for k is equal to 0, we are getting the value as 0. So that is plotted in here. For k is equal to 1, the value is plus pi by 4, that is marked here. And for k is equal to 2, the value is 0, that is marked at this point. For k is equal to 3, the value is minus pi by 4, that is marked in here. So this is called the phase plot of the given x of k. And finally, the applications of discrete Fourier transform. So normally the discrete Fourier transform are used for performing the cross correlation between two given signals, and it is also used for spectrograms. It finds its major application in filters and convolution of the signals, and DFT is also used for correlation analysis between the signals, and it is also used for estimating the power spectral density for any given signal, and it finds its application in the matched filtering, and coherence function measurement is also possible using the applications of DFT. So in this presentation, we have seen the DFT and its properties, and how to find the DFT with the formula method and its applications. Thank you.